Hello dear students, today we are solving ISI 2020 subjective paper. So I have solved till 4 in the last two videos. So today we are solving from 5. So here we are working with the pentagon in terms of the area. Prove that the largest pentagon in terms of area can be inscribed in a circle radius 1 is a regular polygon. That means all of its sides are equal. Okay, so let's see. So we are given with a pentagon, 5 sides, and it is inscribed in a circle, and circle in a circle of radius 1, and this will become regular if the circle is this. So let's draw this first. Okay, I think I can do one thing. So now we have this circle, and the polygon based diagram will be like this, and you can make it with respect to different triangles. So how many total? 5 isosceles triangles. Okay. So now let theta I is an angle. Okay, so where I this lies between 1 to 5 be an isosceles, be the angles of the triangles between equal sides. So the length of these sides, length of the sides, L of sides, are equal to the radius of the circle R. So radius of circle R, or smaller here. So now the area of the triangle is 1 by 2 capital R square sine theta I. Okay, so the area of the pentagon is R square by 2 summation of sine theta I, where obviously I equal to 1 to 5. Now we have theta I lies between what? 0 to pi, that is 180, and the function x tends to sine x, and sine x, this lies between 0 to pi as well. Okay, but this is non-inclusive, this is inclusive. So now summation of sine theta I less than 5 less than equal to sine of summation theta I by 5 equal to sine 2 pi by 5. So now we have this sine theta I equal to 2 pi already. So the area is area of the pentagon A less than equal to 5 by 2 sine 2 pi by 5, as r equal to 1 they have given at the end. So the equally, so this is the structure, and this is equally achieved when theta I equal to 2 pi by 5. So that is only when the pentagon is regular. Hence the answer, and it is proved. So now we get to the question number 5 is being done. 6. Prove that the family of curves is one of the most very common cited question, x square by a plus lambda plus y square by b plus lambda equal to 1. This satisfies this as well. Only the next parts changed a little bit, so we will have a look into this. So what we have here, 2x by a square plus lambda 2y dy dx by b square plus lambda equal to 0. So y dy dx is minus x into b square plus lambda divided by a square plus lambda. Once it is been done, then it is x plus y dy dx equal to x 1 minus b square plus lambda and a square plus lambda equal to x into, so this will be a square minus b square by a square plus lambda. And obviously in the other part, x dy dx minus y will be x by y. This is y dy dx minus y. So this is minus x square by y b square plus lambda. Here putting the values here, minus y. So b square plus lambda by y can be taken common. So x square by a square plus lambda and y square by b square plus lambda. So that is equal to minus b square plus lambda by y. This has been done. So it follows that, now this thing is following, x plus y by dy dx, x dy dx minus y. So minus x a square minus b square by a square plus lambda and b square plus lambda by y. So once we put it, so the final value comes in as a square minus b square minus x by y. So it's actually satisfying b square plus lambda, a square plus lambda. So dy dx a square minus b square. Hence the answer.